There's a moon orbiting Saturn right now that should not exist the way it does. A frozen world so bright it throws back nearly 3/4 of all the sunlight that touches it, scarred from pole to equator by impacts violent enough to remodel entire regions of its surface, wrapped in cliffs hundreds of meters tall that tear across its landscape for hundreds of kilometers, and hiding, somewhere beneath all that ice, a shape that simply does not match the math. Its name is Rhea, and for 350 years it has been sitting in plain sight, the second largest moon in Saturn's entire system, and almost nobody has ever heard of it. Not because it has nothing to say, because everyone else got there first. Titan steals the spotlight with its alien lakes of liquid methane. Enceladus steals it with geysers of water blasting hundreds of kilometers into space. And Rhea just sits there, quiet, brilliant, ancient, while the rest of the world looks past it toward its louder siblings. But here is the thing nobody tells you about quiet objects in space. The silence is usually hiding something, and the deeper scientists dig into Rhea, the less that silence makes sense. There's an atmosphere here that should not exist on a moon this small. There is an internal structure that refuses to behave like the models predict. There is a shape, an actual physical shape, slightly wrong in a way that hints at something dense and hidden buried inside it. And for years, there was something else entirely. A possibility so strange that if it had been confirmed, it would have rewritten an entire category of planetary science. Stay with this one, because by the end you will understand why some of Saturn's most respected researchers consider this overlooked little ice ball one of the most genuinely puzzling objects in the entire system. Humanity's relationship with Rhea began on the night of December 23rd, 1672, when the Italian astronomer Giovanni Cassini, peering through a telescope that would look laughably primitive by today's standards, noticed a faint T-point of light tracing a slow, patient orbit around Saturn. He had no way of knowing what he had actually found. He named it after Rhea, the Titan goddess of Greek mythology, the mother of the Olympian gods, a fitting name for something that has spent 3.5 centuries quietly outclassing its more famous neighbors in terms of sheer mystery. Today, we know Rhea as the second largest of Saturn's moons, smaller only than Titan, with a diameter of roughly 1,428 kilometers, just about half the width of our own moon. It circles Saturn at a distance of approximately 527,000 kilometers, completing one full orbit every 4.5 days, and like our own moon, it is tidally locked, forever showing the same frozen face to its parent planet, eternally staring at the gas giant that commands its existence. Its surface is one of the most reflective in the entire solar system. Nearly 70% of all sunlight that reaches Rhea bounces straight back into space, a brilliance produced almost entirely by a thick blanket of water ice coating nearly every inch of its surface. From a distance it looks serene, clean, almost peaceful. But that calm, polished appearance is, in the most literal sense, only skin deep, because the moment you look closer, Rhea tells a very different story. Its surface is absolutely saturated with craters of every conceivable size, each one a permanent scar left by an impact that occurred billions of years ago, as if the moon has spent its entire existence silently recording every act of violence the early solar system ever threw at it. The largest of these scars, a basin called Tarawa, stretches roughly 480 kilometers across, an impact so massive it would have reshaped entire regions of the moon's surface in a single catastrophic moment. And here is where it gets genuinely strange. When scientists examined the interiors of some of these craters closely, they found something the surrounding terrain didn't share. Darker material, as if the impacts had punched straight through the bright icy shell and dredged up something hidden. Underneath, something the rest of the surface was carefully concealing. These craters are not just scars. They are windows, accidental excavations into Rhea's past, each one offering a brief, involuntary glimpse at materials this moon has otherwise kept buried for billions of years. But even the craters are not the strangest thing etched into Rhea's surface. In certain regions, long, bright streaks slice across the landscape for hundreds of kilometers, and for decades, absolutely nobody knew what they actually were. When scientists finally figured it out, the answer revealed one of the most unexpectedly dramatic landscapes anywhere in the Saturn system. For most of the 20th century, astronomers assumed they understood Rhea reasonably well. The Voyager probes flew past in the 1980s and sent back images of a cratered, frozen world streaked with strange, bright lines, structures nobody could properly explain at the time. From that distance, the leading theory was simple: deposits of fresh ice or patches of lighter material scattered unevenly across the surface. A tidy explanation for what looked at the time like a fairly uncomplicated little moon. Then the Cassini spacecraft arrived in the Saturn system, and everything that simple explanation rested on collapsed in an instant. Cassini's cameras captured detail no one had ever seen before, and the discovery was startling. Those mysterious bright streaks were not deposits of ice at all. They were cliffs, Massive ones, in places hundreds of meters tall, slicing across the moon's frozen crust for staggering distances. These walls of ice most likely formed billions of years ago, when powerful internal forces fractured Rhea's frozen shell, violently pushing sections of terrain upward and leaving behind towering ridgelines of ice that still stand today, frozen monuments to a past that was nowhere near as calm and lifeless as the moon's quiet, reflective surface would have you believe. But Rhea's secrets do not end at the surface. In 2010, another discovery caught researchers completely off guard. Data beamed back from Cassini revealed that this small icy moon possessed something almost nobody expected to find there: an atmosphere, or more precisely, an extraordinarily thin exosphere, so faint that no human standing on its surface would ever notice it was there at all. And yet, Cassini's instruments unmistakably detected oxygen and carbon dioxide drifting around the moon. The amount of oxygen present is trillions of times smaller than what exists in Earth's atmosphere, but the simple fact that it exists at all was extraordinary. The most widely accepted explanation involves Saturn's enormous, powerful magnetosphere. Charged particles trapped inside that magnetic field constantly bombard Rhea's icy surface, and when they strike the water ice, they break apart its molecules and release tiny amounts of oxygen into the space surrounding the moon. The discovery placed Rhea into an extremely exclusive club of worlds known to possess oxygen in their atmosphere, but it also opened an uncomfortable new question that nobody could immediately answer. If a moon this overlooked could hide an atmosphere nobody predicted, what else might be sitting underneath kilometers of solid ice, completely invisible to every spacecraft that has ever passed by? To even attempt an answer, you have to go where no spacecraft has ever actually gone, straight down into Rhea's interior, because if the surface is strange, what lies beneath it might be stranger still. Nobody has ever seen the inside of this moon directly. Everything we think we know has been reconstructed entirely through calculation, gravitational, measurement, and indirect observation from orbit. And yet scientists have still managed to assemble some genuinely revealing clues. The first is density. Rhea's average density is remarkably low, only slightly higher than water itself, which tells researchers that the moon is built overwhelmingly out of ice. Current models suggest its composition is roughly 75% water ice and only 25% rock, a combination so distinctive that some researchers half-jokingly nicknamed it a giant dirty snowball, a name that, however casual, captures the moon's nature with surprising accuracy. Cassini's observations also revealed that the ice on Rhea's surface isn't perfectly pure. Traces of carbon dioxide were found locked inside it, along with hints of possibly more complex molecules, suggesting Rhea's chemical history may run far deeper and far richer than anyone originally assumed. For a long time, scientists believed the interior was relatively simple, a fairly uniform mixture of ice and rock distributed evenly throughout, with none of the sharply defined layers you would find inside a planet like Earth. But not everyone accepted that picture. In 2006, a study proposed something far more provocative. What if, buried beneath kilometers of ice, Rhea is hiding a subsurface ocean of liquid water? The idea remains highly speculative, far from the strong supporting evidence found at moons like Enceladus or Europa, but it is genuinely fascinating because even this far from the sun, certain worlds manage to keep liquid water locked inside them, kept warm by internal heat and gravitational interactions with their host planet. To this day, there is no definitive answer. Rhea might be nothing more than a giant frozen sphere through and through, or it might be quietly concealing a hidden ocean beneath its icy crust, sealed away in total darkness for billions of years. And that is far from the only mystery refusing to resolve itself, because when scientists examined the moon's actual shape with real precision, they found something that, frankly, should not be there at all. Most large celestial bodies naturally settle into something close to a perfect sphere, because gravity relentlessly pulls all of their mass toward the center, smoothing out irregularities over billions of years until the object becomes essentially round. Rhea mostly follows that rule, slightly flattened at its poles and bulging at its equator, which on its own would be perfectly unremarkable. The problem is that the degree of flattening does not match what its current rotation speed should actually produce. It's a subtle discrepancy, but a real one, and it raises an intriguing possibility that Rhea's interior may not be nearly as uniform as everyone assumed. There may be denser regions hidden beneath the surface, irregular pockets of mass distorting the moon's internal structure in ways scientists still do not fully understand. Fortunately, researchers got the chance to investigate this up close thanks to one of the most successful missions in the history of space exploration. For more than a decade, the Cassini spacecraft explored Saturn's system, conducting repeated close encounters with Rhea along the way. In January 2011, it made its boldest pass yet, skimming just 76 kilometers above the moon's surface by astronomical standards, an almost reckless, razor-close flyby. The images it captured during these encounters revealed staggering detail. Ancient regions packed with massive craters sitting right alongside smoother, comparatively younger plains, likely formed when enormous impacts launched debris into space that later rained back down, blanketing older craters and resetting parts of the surface's geological clock. But arguably, the single most fascinating discovery to come out of the Cassini mission wasn't something the spacecraft found. It was something it specifically went looking for and failed to find, because years earlier, Cassini's own instruments had hinted at something genuinely extraordinary. Some researchers began to suspect that Rhea might possess its own ring system, something that had never, in the entire history of astronomy, been confirmed around any moon anywhere. The measurements showed particles or structures capable of altering the flow of electrons around the satellite, exactly the kind of signature a ring system might produce. The implications were staggering. Picture a moon with its own miniature ring system, quietly orbiting inside the far larger and more famous rings of Saturn itself. A structure within a structure, a system nested inside a system. But when Cassini finally turned its full attention toward Rhea to confirm it, the evidence simply was not there. No rings were found. No particle system could be verified. It was as if the rings had been suggested by the data and then vanished entirely before anyone could actually prove they existed. To this day, the case remains genuinely unresolved. Some researchers believe the original measurements had a completely different explanation all along. Others argue that some kind of extremely faint and nearly undetectable disk might still be there, simply too thin for our instruments to catch. And in the meantime, Rhea continues its quiet, endless orbit around Saturn, embedded within the planet's enormous outer ring system, a structure built largely from ice particles ejected by the geysers of its more famous neighbor, Enceladus. And maybe that is exactly what makes Rhea so quietly compelling. The more answers researchers manage to extract from it, the more new questions appear in their place. A moon that once seemed like one of the simpler, less interesting objects in Saturn's orbit has turned out to hide an unexpected atmosphere, colossal hidden cliff structures, the genuine possibility of a buried ocean, and a list of unresolved mysteries that refuses to get any shorter, which leaves us with one final unanswered question hanging over the entire story. What else is Rhea still keeping from us? Throughout this journey, we've gotten to know a moon that almost never makes headlines, a world living permanently in the shadow of giants like Titan and Enceladus, yet carrying enough genuine mystery to rival nearly anything else in the solar system. Rhea might look, at a glance, like nothing more than a silent ice ball quietly circling Saturn, but it only takes a slightly closer look to realize there is far more hiding beneath that bright, polished surface than meets the eye. Perhaps some of these questions will finally be answered in the decades ahead. Perhaps a future mission will return to the Saturn system, carrying instruments vastly more capable than anything Cassini ever had. And perhaps, when that day finally comes, we'll discover that Rhea is even stranger, even more complex than anything we currently imagine. But here is something we can already say with total confidence. Rhea stands as yet another reminder that our solar system remains absolutely full of extraordinary worlds, places that for centuries were nothing more than faint points of light in the night sky, but which are now, slowly and patiently, revealing astonishing stories about their origins, their evolution, and the secrets they've kept buried for billions of years. And maybe that is the real lesson this distant little moon has to offer. The deeper we explore the universe, the more clearly we see exactly how much we still don't know. Somewhere out there right now, silently orbiting Saturn, Rhea continues reflecting sunlight back into the depths of space, an ancient, frozen, seemingly peaceful little world that may still be holding the answers to questions we haven't even learned how to ask yet.